Very good afternoon to one and all. Today we are going to see about the load curve and load duration curve. So how we are going to plot the load curve and load duration curve. What is the use of these two curves, and how to calculate the number and size of generating units and all we are going to see. So if you see like a variable load on power system, the load on the power system, as I said, the load on the power system varies from time to time due to uncertain demands of the consumers. Uncertain demands on the consumers, and is known as variable load on power station. So we can't predict like the load on the power station. This time will be like this much megawatt, like that. We can't able to predict. It may be varying like anything. So if you stand in the load dispatch centers, you might be seeing all these things. One time it may be going up, or one time it may be going down, one time it may be moderate. Like that, we can't predict. So that is the due to uncertain demand. So we can't know like when the consumers is consuming, when the consumers is like going to on the iron box, or when the consumers are going to on their air conditioner, like that we can't know. It is especially meant of the consumers and what time they are going to use. So it is varying like anything. That is called uncertain demands. So what is this effect of variable load? So due to the effect of variable load, so we need some additional equipment. Additional equipment like the transformer size might be increasing. Then the conductor size might be increasing. Then the generator size might be increasing. Then raw materials for generating the power like coal, water, that also might be increasing. So like that, the raw materials also might be increasing, and also the equipment also might be increasing. So like in the modern power plant, there we can adjust the rates of supply of raw materials according to the demand. Like in the modern power plant, if you go for the like old substation or old power plant, in old substation, there will be one single panel. If you go inside the substation, there will be one single panel in which they will be displaying your power factor, then your frequency and all. That is of analog meters. So accuracy, you can't expect that much accuracy with that analog meters, even though you can see the 50 hertz or 49.75 hertz or 49.9 hertz, like that you can see. But even though we can't able to expect the accuracy of that plant, accuracy of that meters, whatever the reading we have taken. And nowadays, and also the backup transformers and backup generators, reserve generators and all might be few. So now in the modern power plants, modern substation, the backup generators, reserve generators will be there. Then backup equipments might be there. So simply like that, if you like one transformer fails or one feeder fails, you can switch over. You can change that bus to that particular feeder, so that you can switch over the things easily. Switch over the transformer rating or switch over the feeders very easy, and also increase in the production cost. So due to the variable loads, so production cost might be increasing. That is if you are having this much tons of coal, you need some other, say for example 2,500 tons of coal you are having now in the coal handling plant. So sudden increase, you want another some over 50 tons or 100 tons more. for generating that much power. So you need to get to that, okay, get that, or some like a storage you need to take like that. And also production cost. So the storage they will be taking now. So they will be taking for tomorrow's tomorrow. They may expect like, or in a month they may expect like which this much tons of coals might be used for generating the power for the whole month. But you are taking tomorrow's sources also, tomorrow whole resources also. Some 10% you are taking for today. And so there is a scarcity of scarcity of coal for tomorrow, and or otherwise. So if there is a scarcity, what they will do is they will simply purchase another some 500 tons or 1,000 tons, another thing they will purchase. So production cost might be increasing. So production cost increasing means automatically your tariff also might be increasing. Tariff also might be increasing. So that also here taken into the account. And also the floor area required also will be more. And suddenly boilers, you need to add some additional boilers, and you need to add some additional alternators, generators also you need to taken care of. Next. So what is the load curve? So load curve is nothing but the curve showing the variation of the load on the power station with respect to time. Okay. So if you see the load curve, so in substation and all, they will be having the load curve of the previous month or previous year, same day. Today is 16th April 2021. So previous year, the same day, 16th April 2020 data also, they will be having in their hand. That is the load curve. So how the load is varying over the today. Say for example, today in our state, in Telangana or Tamil Nadu or Karnataka, Kerala, Pondicherry. So what is the today's load? The today's load, whole load. So say for example in Telangana, today the maximum load capacity is 13,500 megawatt. So like a load is 13,000, demand is maximum demand is 13,500 megawatt. So from morning, from 12 midnight to morning, that is noon 12, and up to again 12 midnight. So in the whole day, 24 hours, how the load will be varying. Okay, so if you see this, this is the load curve of a particular small example is being given. I think maximum demand in this is 6 megawatt. So like 12 midnight, it might be varying very slowly. Why? Because domestic load, that is domestic consumer load will be less, and industrial consumer is somewhat will be there. So the load is very less, like around 1 megawatt in that particular area. Maybe this is plotted for a particular area. So 1 megawatt. So 1 megawatt, like slowly it is increasing. After 4 o'clock, it is slowly reaching up to 2. After 6 o'clock, it is slowly reaching up to 4. And after 7 o'clock, it is slowly reaching up to 4.5, 4.2, like that. It is slowly increasing, and again this is the peak time, 7 o'clock to this 9 o'clock. 9 o'clock is peak time. So after that, slowly the domestic load is decreasing, and after that industrial load is getting started. So industrial load slowly it is increasing again to 4 megawatt in that particular area, and again slowly it is gradually like 12 noon it is rising, and again in the afternoon, like 2 to 4, it is like it is average, and after for 4:30, like slowly increasing. So after 4:35, it is the peak time for the domestic load, and the industrial load somewhat decreasing in that particular time. So slowly it is increasing up to 6 megawatt, like peak time. This is the peak time, 7 o'clock, 8 o'clock, and slowly it is reducing to 4 megawatt, 3.5, like that, and again it is being reduced. So like that, you can also, I think all are you're staying in your home. Today, from today, what you have to do is from today 6 o'clock, you go evening 6 o'clock, you go near to the your energy meter. So energy meter, your load, you load in kilowatt hour, it will be displayed. So 1 hour once, 1 hour once, you have to go near to that your energy meter. So 6 o'clock, you just note down what is the kilowatt hour. Then again, you go up at 7 o'clock. In the 7 o'clock, you note down what is that particular energy it is being consumed. Like that, 8 o'clock, 9 o'clock, like that. You just go to your near to your energy meter, and you just note down what is the power, what is the power being consumed, what is the energy is being consumed in our home. Like that, you note down 7, 8, 9, 10, 11. I think up to 12 you can note down. After that, maybe if possible, if it is possible, you can also note down the like 1 o'clock, 2 o'clock, then 4 o'clock, then 6 o'clock. Like that, also you note down 2 hours once. You note down if possible. Possibilities are there. Like that, if you note down and you try to draw the load curve for your own home, uh, home, how the energy is being varied, how the load is being varied in your home from like 12 midnight to maximum 12 midnight, one day fully. Like that, you can easily note down. One day you just spend the time. So it might be very interesting to draw the own load curve of your home. So how the load is varying in your home. So in the what type. So by knowing the load curve, you can easily identify what is the maximum demand in our home. In which time we are using maximum demand. Maybe like your evening time from 5:30 to 8 o'clock or 8:39. Like that. That is the peak hour in your home. So in that time, how many lights, fans will be on in that particular time? By analyzing that, how you can reduce that, also you have to think how this peak load, how we can reduce. How we can reduce means some lights will be unknowingly somebody like that switching on, like that they simply like that going and fan loads. Like that, if you off like that after 1 week, again you just note on all your readings, again you plot. Then like that, your like electricity bill also you can reduce for your home. So like as I already said, by knowing the load curve, so in substation what they will do is they may predict the load, how the load they the substation, they might be having the previous year load, no, previous year load for the particular whole Telangana state. What is the previous year load in the today's date? What is the load? So from seeing that load curve, they may analyze, they may predict this year 2021 also, the load might be somewhat averagely, it might be 13,000 instead of, so previous year might be 13,300. So this year might be some 200 megawatt or 500 megawatt extra they might be generating. So based on the seasons, based on the today is falling under summer season. So summer season that might be increasing than the previous year. So previous year also summer season same 13,200 megawatt means. So this year also like 13,000 500 megawatt. So to 300 megawatt like that we are generating more. So like that we can predict the load also, and even hourly also we can predict. So hour wise, say in Telangana, hour wise, what is the 12 to 2? What is the hour wise load variation? So which are the generators we should on? Like that also load dispatch also you can do with that load curve. without load curve, load dispatch also they may so which generators we should on in the particular time. Say for example 12 to 2. So this is the particular time very less. So we can off the generators. So we can off the generator means what is the optimal generators? Optimal generators means least cost generators. So which are the least cost generators for this? Like that we you can on like a hydro or wind or from renewable energy resources. Like that you can on this particular time. So say for example this morning like 7 o'clock 6 o'clock to 9 o'clock is the peak hour for the domestic load. So by that time, how can we manage? How can we manage means, so what they will do is simply, so what they will do is simply they will on the base loads like thermal generating station for particular hours. So for peak hours. So again, this load will be off for domestic loads. Domestic loads after 9 o'clock load will be off. So 9 o'clock to again 12 o'clock will be peak time for the industrial loads. Industrial loads. So how can we manage industrial loads? Also, we have to supply reliable power. Even domestic load also reliable power. So if deficit is there, industrial loads if you cut means again there will be some loss for the industries, huge loss for the industries. If you just cut 2 hours in a day for a like industrial load, they might be getting loss of like 1 lakh or 2 lakhs or 5 lakhs. It depends on the company. Depends on the company. So huge amount of profit they might be losing. So by that time, what they will do is, like deficit is there in the particular day. Say for example today, 16/4/2021, deficit is there for 2 o'clock, like 2 p.m. to 4 p.m. Some deficit is there for 2 hours. So what they will do is from the substation itself, they will call to whichever the industries that is being connected to that particular substation. What they will do is they will priorly inform 2 o'clock to 4 o'clock there is a power deficit. We can't able to provide the power for you within the particular time. So better you can avoid. You can go for some other work. So in companies, what they will do is they will go for a packing. They will go for like logistics works like that. They will do whenever the power is not there. So like that they will accordingly they will plan their works. So they will go for logistics or some other cleaning work or some maintenance work they will do. Something like that. It depends on the company. So they will utilize that workers because they are giving salaries. 8-hour shift in industries, 3 shifts, 8 hours shifts they are entering. So they are giving just like that salaries. So what they will do is they will allot that particular persons. Those are they are working workers to so they will allot some 2 hours to some other work, so that they can do that work, maintenance work or cleaning work or logistic works, like something like that. They may go for that particular work, and they may they may easily manage that particular work. So in domestic, so they might not be intimating, like deficit is that they might not be intimating, because domestic sometimes in afternoon hours, many of us will be work, in the work in their work. So only few members were in like houses. So they might be utilizing the appliances and all will be very less. So in that particular time, so even half an hour or 1 hour they will off also. Nothing will be affected. So in that time, some very few people might be staying in our home. Like so that also they might be not. So if they are going for 8 hours power cut in the domestic load, in the say for example they are going for maintenance work tomorrow 17/4 2021, they are going for maintenance work in a particular area. In that particular substation around that area alone, they are going for maintenance, which they will be telling in radios or in TV news channels, local news channels, they might be intimating you. So today, this particular area, we are going for maintenance work from morning 8 o'clock to night, sorry, evening 6 o'clock. There might be not having any power. Like that, they might be purely intimating. So by that time, what we will do, like domestic users, will go for our works previously itself. Instead of going ironing at 9 o'clock, we'll be ironing at early hours itself, 6 o'clock. And even for grinding some flours, something like that, we'll be doing our works purely itself. So that we'll avoid that. Like in that particular time, we can go for some other works. We'll be utilizing with our inverters for sometimes. That too, like 8 hours, we are getting some power cut from 9 o'clock to 6 o'clock, like that. Some 8 hours, so more than that, 10 hours also we are getting. So by that time, what we'll do is we'll utilize with our inverters, but we'll not utilize like more loads, like iron box will not operate, and so we'll on only few loads if we are having inverters. If we are not having inverters, we have to simply like that, we have to manage that particular day. Like that also we will do in that. So in this load curve, we can easily analyze. So load curve, we can easily analyze what is the maximum demand of that particular area, or the whole Telangana state. What is the maximum demand? So what is the average demand? Averagely, what is the load, and what is the minimum demand? Minimum demand. So for that, they will be giving the instruction to the like generating station. So generating station also will be generating that particular thing. That particular generation, they will on or off based on the demand. So this is also one of the things. So what is the importance? So daily load curve have attained a greater importance in generation as they supply the following information readily. The daily load curve shows the variation of the load on the power station during different hours of the day. So different hours will able to note down the variation of the load, and also area under the daily load curve gives the number of units generated in that day. So whichever the what are the units generated in that particular day, that also you can easily analyze. So unit generated per day is nothing but area in kilowatt hour under the daily load curve. So unit generated also we can easily analyze. And also one more thing, the highest point on the daily load curve represents the maximum demand on the station on that particular day. The highest point on the daily load curve represents the maximum. So here what is the highest point? In this example, 6 megawatt. So this represents the maximum demand on the station on that particular day. So that also we can easily analyze. So what is the maximum demand on that particular generating station over that day? In the generating station also, they will be drawing this load curve. So load curve. So how much we have generated. So that also they will draw. They will draw and keep. They will draw and restore in a. So nowadays, due to the modern equipments, modern computer technology development, so we can easily analyze in the computer itself. So previously, what they will do is they will use to note down the readings in their note. One notebook will be there. So frequently they will be noting down. Hour-wise, half an hour once, they will be noting down. So after that, end of the day, what they will do is they will be drawing a small load curve, and they will be storing in that particular note itself. So easily, like that, yearly one note will be there. So easily, if they take that note, if they just see that that particular date, they can easily understand. So nowadays, it is very easy. So due to the technological development, So if you just enter the date 16/4/2020, so you can easily get the previous year load. So by that you can compare also. So you can compare also. You can predict. The computer software itself will be predicting, and it will be showing. So this is the approximate load demand in today's date. So you can generate today's rate. Like that also you can easily tell, easily analyze and easily predict. So this also. Next, area under the load curve divided by total number of hours gives the average load. So average load also we can easily estimate. That is, average load is equal to area in kilowatt hour under the daily load curve divided by the hours in a day. That is 24 hours. So that also you can easily analyze. So this is the formula for calculating the average load. So area in kilowatt hour under the daily load curve divided by hours in a day. That is 24 hours. So if you want for daily loads, you have to go for 24 hours. If you want average load for a month, then 24 hours into 30 days. Like that. If you want average load in a year, 24 into 365 days. So 365 days. That also you can calculate. So next is load factor. So load factor is average load divided by maximum demand. So that is, load factor is nothing but the ratio of the average load to the maximum demand. That is, ratio of the area under the load curve to the total area. So of the rectangle in which it is contained the load factor. That is, load factor is nothing but ratio of average load to the maximum demand. So average load, how to calculate average load? Average load into 24 hours. So and also maximum demand into 24 hours. So that also by easily you can calculate the load factor. So next, this load curve help in selecting the size and number of generating units. So what are the, how many generators we should on, and also how much megawatt you should generate. So that also you can easily analyze by analyzing this load curve. And also load curves help in preparing the operation schedule of the station. Operation schedule in the sense in which hour we have to generate how much megawatt. Say for example, 12 p.m. to 1 p.m. So what is the load? 12 p.m. to 1 p.m. 13,000 megawatt. So how many operation schedule of the station? In that particular station, like 1,500 megawatt is the maximum installed capacity. So that 1,000 megawatt you can maximum generate. So like that, many generators will be there, 100 generators will be there, or 50 generators will be there. So that 50 generators, how to manage, how to schedule that, how to schedule, say, for example, this much megawatt, 500 megawatt, 1,000 megawatt. Like that, we can easily schedule that, and you can easily prepare the schedule for that particular generating station also. That particular generating station, this time 12 to 1 o'clock, 1,000 megawatt. After some time 2 to 4 o'clock, only 500 megawatt is enough. After 6 to 8 o'clock, 1,500 megawatt. Like that operation schedule also you can do for this particular thing. That also you can do for this by this analyzing this curve. And here, if you see, what is the connected load? So connected load is nothing but it is the sum of continuous ratings of all the equipments connected to that particular supply system. So connected load, it might be of like infinity. If you take like a how many like equipments connected to a particular substation, also you can't predict. You can predict approximately. You can predict like based on the domestic load. So this many like 1,000 domestic loads are there, and the industrial loads are of 30 industrial loads are there. Like that, you can approximately predict. So in that, say for example, single phase supply, how many of them are using single phase supply? Single phase supply means approximately 10 equipments. Three phase supply approximately 20-25 equipments. Like that, you can simply predict, but you can't exactly tell how much equipments it may be connected. Like that, connected load might be of increasing like anything, and also you can't predict simply like that. But you can go for like approximation. You can go for. So how to analyze the connected load is like sum of the continuous rating of the all the equipments connected to the supply systems. So from that, you can easily analyze the connected load. So how to analyze the maximum demand? So what is the maximum demand? It is the greatest demand of the load on the particular power station during the given period. So it is the greatest demand of the load on the power station during the given period. So what is the greatest demand of the load on the particular station, power station? So substation, what is the greatest demand? Say particular substation rating is the demand is 5 megawatt or 10 megawatt or 20 megawatt, like that. So 20 megawatt is the maximum demand of the particular substation. Like that, you can easily analyze. And also by seeing this load curve also, say for example, this is the load curve of a particular substation. By seeing the load curve also, they can easily analyze what is the maximum demand of that particular substation. Like that also, you can easily analyze from that. It is the this is the definition. That is the greatest demand on the load on the power station during a given period of time. So given period of the time is, so here we are analyzing for 24 hours. Sometimes 30 days data might be available. Sometimes the whole year data might be available. So it depends on the which data you will be analyzing and which data you will be asking. Next is demand factor. Demand factor, how to calculate demand factor is that demand factor is nothing but ratio of the maximum demand on the power station to the connected load. That is called demand factor. So that is the maximum demand by the connected load. So by easily analyzing the demand factor, so usually the value of the demand factor is usually less than 1. Why? Because it is expected, because maximum demand on the power station is generally less than the connected load. So maximum demand might be generally less than the connected load, because maximum demand we are simply we are predicting the maximum demand, say for example, maximum demand of whole particular state is 13,500 megawatt. We are predicting, but connected load is somewhat less. Somewhat less is 13,300 megawatt, 1,400 megawatt. So 1,100 megawatt, what we are doing is we are generating more. So generally, the value of the demand factor is usually less than 1. Less than 1. If it is greater than 1, then the maximum demand is high. Then whatever connected load is, maximum demand is less and the connected load is more. So demand is less and the connected load is more. So demand, whatever the demand we are predicting is 13,500 megawatt, but the connected load is 13,600 megawatt, more than that. So generally, it should not be like that. If it is like that also, your power factor and your frequency profile, everything might be changing. So generally, in substation, they will not go beyond the demand factor. They will not go beyond 1. They will be less than 1. That is 0.95, 0.8, 0.9, like that. It will be less than 1. So if it is less than 1, so power that particular power station is operating correctly. If it is greater than 1, then your connected load is high and the demand is less. That is, generation is less, the connected load is more. So in that thing, the entire load, the entire like substation will be like collapsing, and usually it should not be like that. Okay, that's what I need to tell. Next, so the knowledge of demand factor is vital in determining the capacity of the plant equipment. So capacity of the plant equipment also depends on this demand factor only. Say one example is given in this. If the maximum demand of the power station is 80 megawatt and the connected load is 100 megawatt, so then the demand factor is 80 by 100. So maximum demand we are expecting is 80 and the connected load is 100. So 80 by 100 is 0.8 only. So 0.8 is the demand factor. So this particular substation is operating correctly. Next, average load. So what is the average load? Average load is nothing but average of the loads occurring on the power station in a given period of time. That is day or month or a year. So what is the average load of a particular Telangana state? So average load is somewhat 12,500 megawatt or 12,000 megawatt. Like that, you can easily tell average load occurring on the particular given period. In a day, they will analyze. In a month, they will analyze. Even every month, they will analyze. From January to December, they will analyze. And yearly, what is the average load? That also they will analyze. So average load is nothing but demand. So load is nothing but demand. Whatever the load is connected, that is nothing but the demand. So we see like daily average load. So daily average load is nothing but number of units kilowatt hour generated in a day divided by 24 hours. Monthly average load is nothing but number of units kilowatt hours, that is in kilowatt hours generated in a month divided by number of hours in a month, that is 24 hours in a day into a month, 30 days. So 24 into 30, like that. So weekly means 24 into 7. So yearly average loads, number of units generated in a year divided by 8760. 8760 is nothing but 24 into 365. If you multiply, it will come like 8760. So this is a average load or like average demand. So what is load factor? Load factor is nothing but ratio of the average load to the maximum demand during a given period is known as load factor. So there is nothing but ratio of the average load to the maximum demand. So that is called load factor. So load factor, like if you want a particular, if a plant is operation in 3 hours, say for example, average load into time divided by maximum load into time. Okay, so time is nothing but in hours, 24 hours. Like that, in a day means 24 hours. In a month means 24 into 30. In a year means 24 hours into like 365 days. Like that, you can go for this load factor. What is diversity factor? Diversity factor is nothing but ratio of the sum of individual maximum demand to the maximum demand on the power station. So diversity factor is nothing but sum of individual maximum demand to the maximum demand on the power station. A power station supplies load to various types of consumers whose maximum demand generally does not occur at the same time. At a particular time, like maximum demand of the different types of consumers, various types of consumers will be varying like anything. Therefore, the maximum demand on the power station is always less than the sum of individual maximum demand on the consumers. Obviously, diversity factor will be greater than 1. So in this particular thing, sum of individual maximum demand so the maximum demand on the power station will be less than the some of the demand, some of the individual maximum demand on the station. So some of the maximum demand of the station might be higher than the maximum demand on the power station. So generally, if you take the diversity factor is greater than 1. So greater the diversity factor is, lesser the cost of the generation of the power. If the, say for example, if the diversity factor might be decreasing is less than 1, then the cost of the generation, that is tariff, will be going like anything. So generally, so diversity factor should be greater than 1. So that you have to keep it in the mind. Next, plant capacity factor. So what is plant capacity factor? Is nothing but the ratio of the actual energy produced to the maximum possible energy that could have been produced during the particular given period. So by knowing the what is the plant capacity means, it is the ratio of the actual energy produced divided by maximum energy that could be produced. So by knowing the plant capacity factor, so you can easily say like, so what is the plant capacity of that particular thing? Like that, you can easily analyze. So easily say, so plant capacity is 2,500 megawatt. By seeing that factor itself, you can easily analyze. So this is the average plant capacity that the plant is being generated, like that. So maximum energy that could produce means, so this actual energy produced means average demand into time in hours divided by plant capacity into time in hours. So 24 hours of 24 into 30 or 24 into 365 days. So in general, that is average demand divided by plant capacity. So here, annual plant capacity, as I said, annual kilowatt hour divided by plant capacity into 24 into 365, that is 8760. So that also. So how to calculate the reserve capacity? So reserve capacity, a plant capacity factor in indication of indication of the reserve capacity of the plant. A power station is so designed that has some reserve capacity for meeting the increasing load demand in the future. Therefore, the installed capacity of the plant is always somewhat greater than the maximum demand of the power plant. So reserve capacity, how to calculate the reserve capacity is nothing but reserve capacity is equal to plant capacity minus the maximum demand. So plant capacity, say for example, plant capacity is 1000 megawatt. Maximum demand is 1100 megawatt. So reserve capacity is, so you can easily analyze. So plant capacity is how much I said? Plant's capacity is 1000 megawatt, but maximum demand is 1000. Generally it might be of, in the plant it might be of very less. Maximum demand is 1010 megawatt. 1010 megawatt. So 10 megawatt is the reserve capacity. So 10 in the power like a substation, they might be having some 10 megawatt generating unit. So in that particular reserve, what they will do is they will simply generate that 10 megawatt for some particular time only, because generating the 10 megawatt from diesel generators, you need to spend more amount on that. So generally, the reserve capacity, even though generator might be there, but generally they will on that reserve capacity generator for only few hours, not only few hours, only for few minutes, like 10 minutes, 15 minutes. It will not exceed more than 30 minutes, more than half an hour. If it goes more than half an hour means, generally you need to spend more on diesel, because generally reserve capacity in particular substation that we are going for only with the diesel generator. But in generating station, if you take like in generating station like hydro generating station or in thermal generating station, that simply they will on some other generating units. Simply they will on like a 100 megawatt generating unit in in a hydro power station. Generally they will on like some 10 megawatt generating unit or 50 megawatt generating units, like that simply they may on. So that is called reserve capacity. That is called reserve capacity. And also reserve capacity generator also will be there at the your generating station and as well as your substation. Next is plant use factor. So how to calculate plant use factor? In the sense, it is the ratio of kilowatt hour generated to the product of plant capacity and the number of hours for which the plant was in operation. So generally, the plant use factors is nothing but ratio of the station output in kilowatt hour divided by plant capacity into number of hours of use. Okay, so the total station output in kilowatt hour divided by plant capacity into number of hours in use. So that is the plant use factor. So by knowing the plant use factor, so how much hours that plant is being used. Say for example, thermal generating unit, how much hours? For 4 hours, 6 hours, 8 hours. So like that, usually you can analyze. So how much hours that particular plant is being used. Say for example, if you take like hydropower plant, 10 hours is being used. 10 hours means how much megawatt? So 10 hours is being in operation. So by simply by seeing the percentage, hydropower plant 60%, thermal power plant 40%. So only 40% only that particular day that thermal power plant is being used. So if a hydropower plant only 60%, so only 60% only that particular hydropower plant is being used for the generating the particular say for example 1000 megawatt per particular time. Like that you can easily analyze that analyze that particular plant usage by simply seeing the plant use factor. So generally after this you have to multiply by 100 because you are going for percentage. Percentage means into 100. So easily by seeing the percentage, we can easily see the you can easily see the how much percentage that plant is being used, how much percentage that plant is being utilized. Like that you can easily know by using this plant use factor.